This is a demonstration of the Exact Rebar software, a reinforcing steel and estimating software package. In this demonstration we are going to show how to draw a non-standard beam using Exact Rebar. So in this case we have imported a drawing from AutoCAD, and I'm scrolling in using the mouse wheel, and we are going to put rebar on this particular beam here. So we will now go Plan, New, Beam Slab Rectangle. Click on the top left and the bottom right. Now we want the elevation to be around the next side, so we'd go next edge. So now the elevation is in the correct place. Now the depth of the beam from the cross section is 500, and we'll go next. Now we have a plan, an elevation and a cross section view. Now in this particular beam there is a chamfer there, so we'll draw that. We'll go Plan, Construct, Polyline, and come across 150, then up at 45 degrees, and finish up there. So for neatness we will erase those two lines. So this is how the beam looks in cross section. Now we will draw our stirrups, and the cross section says that the stirrup is an R12 and the cover is 40. So we will click on Auto Offset to create the offsets for the stirrup. And now we will draw the stirrup. By simply joining up the points. Now we can add a bend, and we want to add a 135 degree bend to both start and end. This is showing the bend here, and we'll keep that. Now we have added our stirrup, so now we need to place the stirrup in the section. So we select the stirrup and then move to here and say for the first 0.3L the spacing is 150. For the center 0.4L the spacing is 300, and for the last 0.3L the spacing is 150 again. And now we will say Add Stirrups. Now the stirrups are drawn in elevation and in plan view. So we've now completed drawing our stirrups. Now we'll draw the longitudinal steel. And the longitudinal steel, according to the cross section, is a D25. And we can draw them one at a time. For instance, if we went draw longitudinal and we came down to that point there, we go draw and finish, and that is our one member. We can also draw them several at a time, so we can say go move to there and move to there and go finish. And similarly draw longitudinal up here. And go finish. Now we have drawn our longitudinal steel, and they can be seen in plan and elevation. Now we want to extend the longitudinal into the column by 150, so we will click on them and select them, then click Trim and Extend, both start and end 150. And they are shown in red here, extending into the column. Now we wish to turn down that steel by 90 degrees, so we will click on Add Bend, and it's 90 degrees, and we want to add bend to both start and end, and we'll reverse that so the bend is down and keep. So now we have our steel bent down and extended into the column. So we'll go close and close, and here is the beam that we have now applied the reinforcing to. We can put it into 3D, and we can go to the colour map, which can show the beam in colour, and we can rotate it in real time. Zoom in. Once we're satisfied that we have done that correctly, we can go to the quote screen. And here is a complete costing based on the pricing in the database. We have a bill of materials showing the quantities used. We also have a drawing of the steel, and in this case giving the outer dimensions of that plus the bending scheme. Plus there's 28 and the total length is 1240. We also have a optimization report giving the most optimal cuts for that particular steel. So waste is reduced to a minimum. That is a brief overview on using Exact Rebar to draw a non-standard beam and place reinforcing in it.